Hi everyone and welcome to DCO. My name is David Capetti, and in this video I'll be sharing how to create this suspended light design that was created here inside a Grasshopper. At the end I'll be showing how I turned it into something like this. We can change the color, we can change the design around. So that's one of the options that I baked in. And if we go here to shaded mode, and if we hide everything, let's go back to the design. And so here you can probably see that it's a straightforward design. I'll be actually doing all of the steps in detail, and we'll be going over how to take this design from a random generated surface that then we can add and remove points. Then we created another randomly generated set of points that was then projected down, and then that was used to create the suspended light design. So I'll be going, like I said, I'll be going over all of the steps here. So if you have any questions or anything, make sure to let me know. And if you want to access the video, script, and everything you see here, consider becoming a Script Vault member on my website, capettidavid.com. So thank you very much for being here, and let's go ahead and jump right in. The first thing we're going to do for this exercise is notice that the units I'm using are going to be in feet. And then starting with a brand new project, we're going to bring in a plane surface, but honestly, this could be anything. For the most part, I'll be using the plane, and that will represent, let's say, a surface that you can bring in. So you're not limited for it being a rectangle. It could be any shape, but for now we'll be using a base rectangle for this. So let's go here to a plane surface. Here on the plane we'll go X, Y plane, and we can even move this plane up. Let's say if it was off the ground by 10 feet, you can say 10. Construct a point here. Having this be 10, unit of 10 up. So now what we're going to do is plug in a size for X and Y. Let's go here to 15. It'll be 15 by 15. And we can always change this around. I'm starting with it being a little bit smaller, but the cool thing about this is that we can always change the slider and increase the size. Next thing we'll do is we're going to take this and subdivide it using points. Now there are different ways in which we can subdivide this. The two that come in mind would be surface frames or divide surface, and this will give us a U and V point count right on that surface. So now let's change the U and V count to a number of 3 and then less than 15. So we have a slider from 3 to 15. Now let's change this around a little bit. Okay. So now with these points, we are now going to move them down randomly. What this is going to do is then give us kind of like a topographical surface that will be kind of wavy randomly. And that will be kind of the surface that we'll be projecting the other set of points onto. Great, so now that we have this, we're going to visualize that we have these points and we want to move them down randomly. So we need to bring in a move component, and the motion is going to be unit Z and then negative for it to come down a specific amount. So now let's plug these points in, and we see that it moves it down by the same amount. Now one of the things that we need to notice is that the points will probably be flattened because it's going to organize the information that way. But other than that, the thing that comes to mind is that we need to know exactly how many points we have so we can generate the exact number of points randomly. So what I do is I'll take list length, which will give me the exact number of points that we have. So here under the list length, I'll go to quotation marks. Now we can actually see how many we have. So we have 64 points. The reason why that's critical is that's going to be one of the inputs for our random number. So let's go ahead and move this over, and we're going to bring in a random. So this is going to generate a random number. And for the set of numbers, so this is how many total number or values you want. So that would be 64. I can obviously skip this, but this is more to show you how many points we have. Then seed is going to be like a randomized option, and then range, we need to construct that. So I like to use construct domain, and this will give us a start and end point that we can plug into the range here. So we'll go start at 0, we'll go 0 less than 3.5000, and we'll copy that one twice and use it doesn't matter which one we use, as long as one is different than the other. Then we can actually see here that we have 64 values, and they're random between 0.1 and 2.45. So the reason why we want that random number is because here we only have one value that we plugged in, and this is why it's kind of static. Because if we plug in a slider here, it's only one number, one value that it changes. Now we're going to bring in that random number. And I kind of like to organize it a little bit here. Sometimes I get a little carried away, but let me plug in now into the motion, which is Z down. We're going to plug in the random values. Now this is why I said that the numbers need to be flattened, is because it generates 64 numbers, and here it's bringing them out in sets. So here, if we go to flatten, it'll take care of that issue. So now let's disable the preview on. Actually, no, we can leave it here. As you can see, we've kind of created some random points moving down, and we can change the number of divisions that we have. For this, we can change the upper and lower number, so we can lower this. And we can also make it be the same. So this takes care of creating those first random points. Now we're going to take those points and we're going to plug it into a component that will create a surface through these points. We're going to go here, double click, and bring in surface from points. Now there are other components that we could use for this, but I think this one actually gives us the best result. So we'll take these points and we'll plug them into the points. For the U count, we actually have to go down here when we see the U division. We're going to plug this in, but you're going to see that it's not going to work. Or actually it does work, but it gives us an issue. We have to do a +1. So I kind of use a relay here, bring in a +1, and that fixes the issue. And it's because the number, you have to add 1 to the U count to account for one of the sides, and that takes care of the issue. So with this surface, now you see we have kind of like this undulated wavy thing that we can use as our base surface to project those random points onto. Or technically there wouldn't be random points, it would be the same as these, but with this you can see, let's lower this. And I'll be changing how many subdivisions we have here. And then we can also, under this one, we can change the direction if we don't like that. And then the seed is going to be more random points or more random solutions. So we'll go to 5 and then plug in. Okay. Something like that looks good. So now with this, we're going to use this as our base surface, and so we can basically hide some of these points that we don't need. We also have this base plane. You can probably hide that also. Now we can move on to creating the random generated, or not random generated points. They're going to be the same grid points, but then they're going to be projected down to this kind of random generated surface. And the surface, what's cool is if we don't like that, we can always change it around and see if there's a better one, or just using the UMB count here. Okay, and the output is also a mesh. Oh no, it's an untrimmed surface. Okay, cool. What we'll do is take this these points that are generated on that surface, and we're going to copy it. Now we're going to copy these two sliders and plug them into here and increase the count. Now we'll disable the preview on all the other ones. And let's increase here the upper limit of our subdivisions. Now we can take these and project them down onto the surface. So we'll go to project point and plug in the points into the point input and go all the way over here and bring in that surface into the geometry. And by default, it says 0, 0, -1, which means it's going to project it down. So it kind of takes care of it for us. And the idea now is that since we have those set of points that we projected down onto that surface, now we can create a line segment between those two. These down here would be the end point, and then the start point going to be these. And since they are set up as kind of grafted sets, it actually connects each point from that one down to this one. I'll disable the preview on the points up here. And as you can see, now you're starting to see the shape of the original surface here. And one of the cool things is we can always change this around to get a different solution. And to keep it light with using, since we have so many subdivisions, and the more subdivisions we create, it's going to get super heavy. We want to take these points and we want to create a mesh. So we'll go here to primitive. We can go to mesh sphere. But if you do have the polyhedron plugin installed, you can use the icosphere, which is the one that I'll be using. And I'll plug in the points into the plane, and the scale will decrease to something like 0.8 or less. And of course, we can always take this and do a point attractor or something like that, where we can change the size of all of the lights and stuff like that, but that's not the point of this. The point of this one was to show you how to create this really cool suspended light system with a base random surface and then this generated grid that's projected down. So lastly, to kind of end the tutorial, what I'll do is I'll show you how to create the top frame and how to connect it to these, so you can have basically that suspended light system with some kind of structure to connect it to. So what we'll do is go to the points that were generated up here, which would be these, and construct that grid. So what we'll do is we take those points and bring in the Delaunay mesh, which I always have a hard time saying, and I don't know if I'm saying correctly, but either way, the points will come in grafted. That's when you see that dash line. So we'll flatten the input. This way it brings them all in one big list, and it then calculates the points and how close they are to each other and generates this. So what we want now is go here to mesh, edges, so we can extract the wireframe using this triangulated look. Now, if that's not the exact look that you're going for, there are other things that we can do to subdivide it, but I actually think that that looks pretty cool. So what we'll do is we'll take this and we'll go to curve, and we'll just bring that into one input. I mean, that's not really necessary. We can technically just plug all of that in, but sometimes it's cleaner to do it this way. So I'll plug all of these in, and then I'll flatten the input. This way everything comes in at once. We have 2601, and so creating a pipe for so many curves would actually make it really laggy. What I've noticed that makes it not so laggy would be using multi-pipe sub D, and that actually helps a lot because it makes it all one, and it's really light, where if we make any changes on the script, then we'll see them update pretty quickly. It also looks really nice in the connections. So let's go ahead and plug that into input. And it's obviously way too big here. So let's go to cap round, and let's decrease the size of this. So I'll go here to, I do this every time and it's because it just kind of works for me, but I'll just show you. So I'll create two numbers that are the same. So 1.5000. Then make sure to have a lot of decimal points because sometimes I'll have to go to a low number. I create two of these and I multiply one to the other. The reason why is because there has to be a proportion between the two for it to kind of work correctly from my experience. And this is what I do. I plug this into the strut size. I plug this into the node size and end offset. And you're going to see that it kind of gets really crazy. So we'll have to decrease all of these, but we'll just have to decrease this one, and you'll see that it'll start to work. So this is why sometimes we have to go to a low max number so we have more slider to work with, if that makes sense. And then we'll do the same thing here. I'll do the upper limit to 2. So depending on whether you want the connection to be larger or not, that's where you do this larger one, this one. This is going to be connection, and this is going to be structure. And so the reason why I say that is because we need to decrease this number more here. We'll decrease this one. So that kind of creates a wireframe for that entire design. And so let's go ahead and bake it and take a look at what it looks like here. So I'll go to a new layer, call this structure. And then I'll hit tab, creates a new layer, and we'll call this light. I'll make my structure layer my current layer, and then I'll middle click and then bake. And I'll do the same thing with the light. I'll make that my current layer, go to the mesh, select it, middle click, bake. Now I'll disable the preview here on don't draw any preview geometry. Let's take a look at this. Now go ahead and turn it into V-Ray Interactive. And I'll see if I can turn off the environment. And then I'll go to the light here, bring in a new material, an emissive material, and plug that into the light. Now let me see if I can bring in a ground plane. And it says automatic, so I'll change that from automatic to 0 because we know that it's at 0. So that's a bit of what that looks like with the render. And we can of course change colors here. And on a future video, I'll be showing also how to create like a randomized or a gradient in color. That would be a fun one. Let me know if you have any questions or if you enjoyed this tutorial. I will be sharing this on my website, cappettidavid.com. Consider becoming a Scriptball member. There we can stay in touch. You can access all of my script videos. And so, yeah, thank you very much for being here, and I hope to see you next time. If you'd like to get a hold of the script that I created for this video, check out my website, cappettidavid.com. There you can become a Scriptball member where you can access all of the video scripts that I've created for my YouTube. You can access also the script store where I have optimized scripts. And lastly, if you want to learn Grasshopper and you've never tried it, or you want to share that with someone, I have a 6-module course that will help anyone get started. I post videos like this that will teach people how to get started using Grasshopper, so make sure to subscribe for future content. I appreciate you being here, and I hope to see you next time.